we will solve this problem of left view of binary tree using level or traversal. That means that we are going to traverse level by level, and we are going to print a story that in a list, and first we will store that. We are going to store it in a list at each level, and whenever we encounter, and while storing the list, we will print the first element at each level. Not print, we will store it in another list or result list. Okay, so by this way, we will be able to get the left view of binary tree. Also, if we have to get the right view of binary tree, then while storing it level by level, so we can get the end element, and we can store it in the reality list, and by this way we can get the uh, uh, right view of the binary tree. Okay, in this video we are focusing the left view, so now let's do that. First one is, again, we will create an array list of integer type. I always list equal to new array list, the same base condition. If like not base, like if the root is null, dash case root equal to null, we have to return this list. Return list. Okay. Now we will use a queue data structure. So what we are going to do, at every level we are going to store all the data of that particular level in the queue. Okay. And while taking, and we will take it out one by one of that particular level. Okay, we will take a, like for this level we have already entered into the into we will take it one by one, and we will the first element we will store it our result, and then we will ignore the just ignore the others one. So now let's move to data structure. Queue type node. Okay, we are typing node queue equal to new linked list. Okay, we will insert the first element dot offer in the root. So by this way we are inserting the first element. Now until and unless this is not empty, while queue is not empty, so queue is empty, what we will do is first we will create a current for, so here we are going to store uh, the, we have to create an array list of integer of the current level. Array list of integer and array list. Basically, it will be a linked list. So we can make also a, this will be current level. So here we will store only those data which are at the current level. Now we will run a for loop, and the for loop will be equal to int I equal to 0, I So let's let the size int length equal to t dot size. So this will give us a two size, and for each of the size, so at every point, at whenever we reach at this stage, so this will give the length of the level, right? At each level, if it has four elements, then the length will be four. If the at this level, then the length will be two. So less than length I plus plus to perform the operation. So what we will do, we will call one element node where you got call, okay, taking out this element, and we will insert it into our integer current level. Current level dot add dot data. So we will insert all the data in our list of integer. Okay. So once, so again it will keep on pulling out each data 1, 2, 3, 4, 5, 4, and it will insert it. Okay. Now it keeps on inserting. It will also pulling out data. We will also fill the data with the child node of that particular node. So q dot offer uh, dot left, and also we will check that if it is not null or not. If dot left not equal to null, then if dot right not equal to null, dot offer parent dot right. So we have inserted the two. So at this stage, so once this operation completed, so what will happen that let's suppose we are here, so it will it will insert 2 and 3 into the current level, CR current level, and it will insert a few, insert 4, 5, 6, 7. The next level will be inserted into the queue, and it is ready for the second operation. Okay, that is that this part is done, and we'll this use that empty. We will again make a list of integer, and name it is a current level. So for this current level, we will again take out the nodes one by one, and we will insert it into that current level list, and and we will also we will for each one of them of the node we will we will insert the child nodes into the tree. Now the list dot, now we have to, since all the operation is ended, so we will take the first element out and insert it into the list. So list dot add the first element will be current level dot get 0. First element. So at every level we are inserting the first element. So all this operation is done. We are ready to return. compilation error. It's fine. We'll check it out. First, we will see that everything is correct. 136. What is the issue? I have entered minus instead of equal. Let's see what happens. That's first. Main compilation error. Limit list I have not entered the spelling correctly. Let's see again. Main compilation error. We got call. We are not in method. We have to call like how method is called in caller. So you also have to check these kind of things in the form. So 154 return. So we are setting okay, we have to enter a return in this right. Let's see. Okay, it's done. Submit it. This is how we do the traversal. Now we will, once it is done, the testing will process, then we will go through the code again and I will explain you the function of this. Let's wait for some time. 200 passed, 500 passed, and all cases have passed. Now, if you see, in order to come to the left view, first we have done is we have created a list, array list. Here we are going to insert all our data of the left view to this particular list we are going to return at the end. Okay. Now if root is null, we will return the empty list without doing any kind of manipulation without awaiting a particular list. Now we will first make a queue, and in the queue we will insert our first root node. Okay, so now since at a level 0, that is the first level, now again while the queue is not empty, until that queue is not empty, so we are going to insert it, then we are going to remove it, we are going to insert it again, we are going to remove. So at each level we are going to insert all the nodes of that level, and then we do some operation, and then again we will remove out all the nodes at that level, and while removing the nodes of we will insert the nodes of the child node. Okay, like we are here to node one at the root node, then we will remove this one and we will insert 2 and 3. Then once we reach this 2, we will remove this 2 and we will insert 4 and 5. Then again we will remove this 3 and insert 6 and 7. So on these 2 and 3 removed, in the queue we will have 4, 5, 6, 7. Then again we will remove this 4 and insert 8, and we will remove 5, 6 and 7. So let's see how we are doing over here. So while choose activity, we have created the list of integers. So here we are storing the integers of that particular level, like this level. If we are at here, then for this current level, we will insert all the data into this list. Okay. Now we will find out the queue size. So this at this point we are getting the length of the level, right? If we have to fill the level size, then we can fill it using this. So this will precise basically the length or size of the queue at that particular level. So number of the nodes which are present at that particular node or particular level will be shown over here. So for that node we will run one by one. We will run a for loop, and for one by one we will take out the one node. First node we will take out. Okay, we will insert it into the current level list. Okay, and from here we will insert in our list for that particular current level, and then we will add in the queue our the child node of that particular node. The child node will be the left view and the left and the right of that particular node that is 4. We will insert it. Then again we will go to the 5. We will pull it out and we will insert it in our list and check to the left and the right child node. If it is not there, then we move to the next node. So once this one is done, once this operation is done, so what we will be left with? We will be left with the list of the nodes, list of the integer of a certain node integer of that particular level. List, all the integer of that particular level we will insert in our list, and again we will move to the and also the all the child nodes will be inserted in our queue. So we will again find out the queue size and then we will go again one by one into the queue and we will insert it in the next we will insert the data integer of that level into the current level and we will again and then we will check for the child nodes. If child nodes are not there, then we will not insert any node into the queue. And at the end, not at the end, when on the operation for that particular level is finished, we will once the yeah, for particular level is finished, we will take the first data of that particular level and we will insert in our list. So this is what we are going to see the left view. And at the end, we will going to return that list. So this list will contain the first element of every level, which is basically the left view of the tree. So that's it.